we finished talking about precipitation and how to do some calculations for selective precipitation. So we're precipitating one ion out of a solution and not another. That can be very useful in something called qualitative analysis. So qualitative analysis is we're finding out non-numerical things, right? Here we're finding out what kind of ions are in a solution. A quantitative analysis is wanting to find out how much, the quantity. So we ran atomic absorption spectroscopy on our green salt samples, and that measured the concentration of iron in the solution you had made. That's a quantitative analysis. Finding out that there's iron in the sample would be qualitative. So this was formerly done using selective precipitation, which is also known as wet chemistry, because you actually get your hands wet, right? Things get wet. It's largely been replaced with instrumental techniques, but the concept here is still pretty neat. And it's in this course outline of records, so you got to learn it, whether we like it or not. That's the spirit. It's feeling a little jaded sometimes. So we think about a sample that has several different metal cations. So here we have cation A, B, and C, and we're going to add a precipitating agent after we silence the family. Well, it's... and everyone else. We'll add a precipitating agent, and that's going to remove cation A. So cation A was the blue one. We added, must be something that's little yellow balls, and that precipitated. So then we can decant the liquid, leaving the solid behind. Now we have a test tube that just has cations B and C in it. We can add a second precipitating agent that is going to precipitate, in this case, cation B. And then we can decant this, and now we've got this solution with just cation A. Does that make sense? Because your lab practical is doing this. So it needs to make sense. Yes.
Question. Would it be cation A that's left or cation C that's left?
I did not make those pictures, but all this time I haven't seen that, so yeah. Good catch on that one. If you have A, B, and C, you take out A and you take out B, you're left with C, not A.
Yeah.
Oh my. In one book's slides, there's a picture of nails, and big nails and small nails, and the point is that there's a dozen of each, except that one of them there's 13. Because I counted, I don't know why I counted. It looked like 12, and I counted it was 13. I'm like, seriously? But I didn't see this, so any other questions about that? So this is a flow chart showing one method of quantitative analysis. Often this is called a qual scheme, quantitative analysis scheme or plan. And so in this one, these are all the possible ions that you might have to start out with. If you add 6 molar HCl, we can precipitate out all the insoluble chlorides. Now, if you have all 3 of these in here, they're all going to come out together, and that might not be what you want. If you only had one of those, then you're in luck. And then to the remaining cations, you can add H2S and a little bit of HCl, and then you'll get these ions that are insoluble sulfides. They're insoluble in acid. Then we can make the solution basic, and there's a whole nother group of sulfides that are soluble in acid but not in base. So you can get those to precipitate out. And then at the end here, adding ammonium, hydrogen phosphate and ammonia, we can get the insoluble phosphates to precipitate out. And then we're always going to be left with sodium, potassium, and ammonium in solution because they don't precipitate with anything. So this is not something that you have to memorize. You need to understand the idea behind it, because you're going to need to make a flow chart sort of like this for your lab practical and then actually do it.
Sorry, it's Grant. I'm an agent of chaos today. I'm so sorry to everyone. You just got him in trouble. Now I have to go apologize to him.
He owes me.
It's okay, it says you can. I'm just causing him so much distress today.
So this is just some details about this. And you don't need to write these things down. Just listen. So you take that initial solution, you treat it with hydrochloric acid. Most chlorides are soluble, but there are a few that are not. And so these three will precipitate out. You can separate the solids from the liquids. And then we're going to use this weak diprotic acid. The concentration of sulfide that's in the solution is going to be pH dependent. So at high hydronium ion, that's what I meant. Hydronium ion concentrations, right? We're not going to have very much sulfide. So that's a low pH, and so only the most insoluble ones will precipitate out. And this is what they would look like. Now, what we're trying to do here is we're trying to identify which cations are in the solution. We are not trying to quantitatively separate them or identify how much. We just want to confirm their presence. So then again, you can separate the solids from the remaining liquid. So then if you add base to this, you make it basic, that's going to shift your H2S equilibria and cause the sulfide ion concentration to be higher, which will make some of the rest of these precipitate. These guys are going to precipitate as sulfides. These will precipitate as hydroxides. And then you've got alkali and alkaline earth metals left. So we can precipitate those out with phosphate. Okay, I think that's a typo too. Because this isn't a correct formula. Anyway, there might be an H2 missing, or I don't know. It doesn't really matter. I'm just getting distracted. So then how can you figure out what those last ions are? Well, one thing we can do is use a flame test. So sodium gives off a very distinctive, very bright, yellowish or orangish yellow flame. And in fact, you'll see this color like in a wood fire, and the color there is from the sodium that was in the wood, right? Potassium makes a purple flame. So you could identify those. And then ammonium would just be by process of elimination. ammonium.
So why would we be testing for potassium if it's not in
Ooh, excellent. What is wrong with these slides? My goodness. Okay.
Because
Wow.
potassium is always soluble as well, right?
Yeah, potassium would be in there as well. Yeesh. Okay, good. Oh my goodness. Thank you.